Hi all. In this lecture we'll see about constants and literals. So from the name itself you know that constant means something that does not change. So before going into constants we will see the previous variable program. So we will take the same program with data.c. So we have this data.c that program. So in this program, I have just used a number. I have declared a number underscore number. I have assigned a value 105 and I am printing that value. So when I print, I will get number dot underscore number will be printed and the value will be 105 will be printed here by this statement. Now I'm going to assign a different value. I'm going to change the value. So as a name is variable, so the advantage of using variable is if you want you can change the value of that variable whenever you want. So I'm going to copy these two lines and I'm going to paste it here. So I'll change the value of this to some value. So let it be 1500 and so I'm going to change the value. So this variable name for initially it is assigned 105, then it is printed. Then after that I am assigning a value 1500 to that number and again I am printing. So as the name suggests, variable means it can vary. So variables value can be altered in the program. Okay, I'll just run this program, colon wq, and you can compile this gcc data.c. Now in order to run /a.out. So initially it is 105 and the value is changed to 1500. So the value of that number has been changed from 1105 to 1500. So variable values can be altered during the program execution. Okay, that's what I want to show. But there are some thing that cannot be changed. So there are some values that cannot be changed during execution of the program. So that is known as constants or literals. So this is the outline of this lecture, constants, literals, and we have this literal or constants are the same thing. Okay, so it can be called constant or literals. So there are integer constants, floating point constants, then character constants, backslash constants, and string constants are there. So you'll see what is a constant and literal. So constants refer to fixed values that the program cannot change during its execution. So if you want to fix some variable, some values to some constants, those values cannot be changed during execution. For example, if you want a pi value, you know the value of pi is 3.14. So you can initialize and declare some pi named variable and you can give it as 3.4 and you can fix it as a constant so that the value will not be changed throughout the program. So fixed values are also called literals. So it is either called constants or literals. So both these are same, constants and literals. So we have integer constant, floating constant, then character constant and string literal is there. So it is treated just like regular variables. It is same as regular variables. As we have seen variables, all those are applicable in the case of constants also, except that their values cannot be modified after their definition. So after we declare and define this variable, we can change in the case of variable. But in the case of constant, after declaring the constant, we cannot further modify that value. So we'll be initially fixing some value for that constant and that value cannot be altered. So we will see some examples. So 100. So if you are giving some assigning some 100 value to a constant, it is an integer constant. Then 200, it is another integer constant. Then within code, single quotes, if you are defining C, then it is a character constant. 3.4, it is a floating point constant. If we are including in double quotes, then it is known as string literal or string constant. So if it is single quotes, it's character constant, and if it is double quotes, it is string constant. So we'll see integer literals. So there are different integer constants. So this can be decimal constants, octal constants, or hexadecimal constants. You may not be familiar with this octal and hexadecimal. You are familiar with decimal because you are from school days you are using this decimal number system. That is, you have digits from 0, 1, 2, 3 up to 9. Then after that you will be using the same 10 digits 0 to 9 digits, and you will be forming other new numbers like after 9 it will be 1 0, then 1 1 1 2 1 3 up to 1 9. Then you will be using 2 0 2 1. Similarly, so that decimal system is known as base 10 system. It is of 10 digits. We have 10 digits and we are using that 10 digits. We will be counting the numbers. Similarly, we have octal numbers. So octal numbers are base 8 and hexadecimal is base 16. So we will see that later. So in integer literals, when we define this integer literals, we will be prefixing prefix will be used to show this base. So which number it is, whether it is decimal, whether it is octal or hexadecimal. If it is decimal, we will not affix any prefix. But if it is octal constant, we have to say 0x or 0 capital X for hexadecimal. So if it is octal, then we will be affixing just 0. We will be prefixing a 0 before that number. And for decimal, nothing will be done. So we will show some examples. Then we can also have a suffix, that is combination of U and L. U stands for unsigned and long. So during data types, we have seen this U and L, and we will not be using all this U and L always. So you just understand that there are suffixes can also be inserted. That is, you can have U and L for to show that it's an unsigned decimal number, or it is an unsigned long in decimal number, like that. So suffix can be uppercase or lowercase and can be in any order. You can use it in any order. I will show some examples later. Then you will understand what is the suffix and all. So we'll show some examples of. Before going into that this system, I'll explain about this numbering systems. So we have different numbering systems. You will be learning about this numbering system in the next semester when you study up switching theory and logic design. There you will be learning about different numbering system and how to convert from numbering system to one to another numbering system. So in binary numbering system, you have only two digits, 0 and 1. So with these two digits, you have to count all the numbers. So the first number will be 0, then it will be 1, then after that it will be, instead of 2, it will be 1 0, then 1 1, then 1 1 0 0, 1 0 1, 1 1 0, 1 1 1, like that it will go on. And octal system, you have 8, the base is 8, so the number digits will be from 0 to 7. So there is no 8 and 9 in octal system. So it will be after 7 it will be again 1 0, then it will be 1 1 1 2 1 3, like that 1 7. There is no 1 8 will be there. After that it will be 2 0, like that it will go on. Similarly, for decimal, you have 10 digits. You know this decimal system you have been using. And hexadecimal, it is of base 16. You have digits from 0 to 9, and there's no 10 here. Instead of 10, it will be A. Then 11, it is B, C, D, F. F is 15. And after that, if you want to have 16, then it will be 1 0, then 1 1, 1 2, like that it will go on. 1A, 1B, 1F, 1F. After 1F, it will be 2 0, 2 1, like that it will go on, and until up to 2F. Similarly, it will go on like that. So it is known as hexadecimal number system. So we have various numbering systems. So this is used inside assembly code and all. When you use assembly programming and all, you have octal number system, hexadecimal number system, all these is required. So that is why you will be learning about numbering system in later semesters. Now you just understand that there are various numbering system. It is not decimal system at all. There are other numbering systems also. So this is a numbering system. So it is 0 1 to decimal, you have 0 1 2 3, like up to 16, 16 17 18, it will go on like this. For binary system, it will be for 0 it will be 0 0 0, then 0 0 1 1 0 1 1 1 0 1 1 0 1 1 1 0, like that it will go, because we have only two digits, 0 and 1. So hexadecimal, it will be 0 1 2 3 9, And for 10 it will be A, then B, C, D, E, F. After that for 16 it will be 1 0. And for octal it will be 0 1 2 3 up to 7, and instead of 8 it will be 1 0, because we don't have an 8 in octal system. So 1 0 1 1 1 2 1 7, and instead of 16 it will be 2 0. So it will go on like this. Okay. So we'll see some integer literal examples. So 105, this is a literal. It is an integer decimal number. Then 0234. So since 0 is used as a prefix, it means it is an octal number. 234 is an octal number. Then 0x4b. So it is we have a prefix 0 small x. So 4b is a hexadecimal number. Then 0 capital X 4b. It also means this is a hexadecimal number. So we can either use 0 small x or 0 capital X. Then 60. So it is a integer number. Then 60u. If we are using 60u, we have already mentioned that you can have suffix also. 60u. It means it's an unsigned integer. 60 unsigned integer. Then 30L, it means it is unsigned, it is long integer. Then 85UL, it means unsigned long integer. And you can use the reverse manner also. You can use 85LU. It also means unsigned long integer, and it can be capital letters also. So the order does not. So we won't be using all these literals. We will be using some integer literals like 105. We won't be using octal or hexadecimal during program. You should understand that we can define this integer, hexadecimal, octal, and unsigned. All these literals can be defined in the program, but we won't be using in program at all. So you not confuse all these things. Next, we have this floating point literals. So here it has an integer part, a decimal point, a fractional part, and an exponent part will be there. So it can be either in decimal form or in exponential form. So decimal form will include the decimal point, the exponent, or both. So exponential form will be include the integer part, fractional part, or both. So I'll show some examples and you will understand what is this floating point literal. So this is legal floating point literal, that is a pi value 3.14159. So this is a floating point literal. I don't know whether it is pi value. Anyway, it is a floating point literal 3.14159. Then this is also a floating point literal. This is also legal 314159e minus 5. This means it is 315159 into 10 raised to 10 raised to minus 5. So 10 raised to, it means it is equivalent to 3.14159. So these two are legal. So we won't be using all these notations. You can simply define like this. Then this is also legal 10.125. Then it is legal 10.5 e raised to minus 3. So this is also legal. This L stands for long. Okay. So 10.5 e raised to minus 3. It means 10.5 into 10 raised to minus 3. Then 510e, this is illegal because exponent part is not complete. So we have to give some exponent part also. Then 210f, this is illegal. There is no decimal here. There are no decimal or exponent is included here. Then point E55, this is also illegal because integer or fraction is missing here. We don't know which is missing here. So that's all about floating point literals. We'll see some example programs later, so we'll understand why do we need this floating point literals and all. After going to all this character constants and all, we'll see some programs. Then character constants, so it will be enclosed in single quotes. So example, inside single quote we will be using x, so it is of character type. So examples of single, like we can store like this within single quotes x or r or t. All these are character constants. Then there are special character constants, or we call it as escape sequence, or we call it as backslash constants. Backslash constants are also there which can be used. So I will show some examples. So we'll be using slash t or slash n. We have already seen the slash n. it is a new line character. So within quotes we can have this character constants also. Then these are some of the backslash constants. So we won't be using all these backslash constants always. We will be mainly using this slash n and slash t. That is why I have given in bold letter. So slash n is for new line and slash t for horizontal tab. Then we have slash v for vertical tab, or slash a beep sound, slash b for backspace, then slash for f for form speed, carriage return, vertical tab, then single quote, slash double quotes for double quote, then double, it is for backslash to print this, backslash slash zero for null. So we won't be using all this. We'll see examples for the slash n and slash t. So I'll show an example program for this. We will write a simple program to show this thing. So I'll name it as escape.c. Okay, I'm going to insert. So hash include stdio.h. So this is a header file. Then I'll have this main function. Sorry. In main, then braces, open braces, then I'll be printing something. So I'll print f. I just wanted to show the slash n and slash t use. So I'll have a slash hello, and I'm not going to insert a space. Instead of, I'll be using a slash t here, and I'm going to print world. Then I'm going to use again slash n. I'm going inserting two lines, and I'm closing this double quotes. Okay, semicolon. Then again I'll print another statement. If I'll copy the same statement here. I'll copy the same statement here. I'm printing it twice. Then I'll include another statement, print f. I'll just change, I'll include two or more slash t values. I am inserting two slash t, or let it be three slash t. So you'll understand why I have used slash t. And world. Then I'll give some slash n. I'll just close it and end with a semicolon. Okay, so I have inserted, instead of space, I am inserting some slash t here, some new lines here, some new lines. Okay, then I have produced another statement, print f. Okay, now I'll use hello, and I'm going to give a comma, and I am simply inserting a single slash here. So we won't be using all these things always. I am in the next nail, I am printing this deer. You need not worry about the slash at all. This is to show that this is also belongs to the same line. You'll see the output, then you will be familiar with this thing. Then I'm closing it and a semicolon. Then the final statement, there should be a return statement, and I'll close this brace. So I am giving some three or four printf. So first printf, instead of space, I am including a slash t, and there are two new line characters here also, slash t and slash n. Then here also three slash t. Then after that a slash n. Then here hello, and in the next line I am including a hello comma, after that a slash, and in the next line I am writing something here. Okay. Now I'll save it and quit WQ. Now GCC escape.c. So there are no errors. Now I have to run this dot slash a dot out. So if I run this program, you can see that we have inserted a double tab here. So two tabs have been, horizontal tabs have been inserted here. So there are some spaces. After that, again, I have used two new lines. That is why it has skipped new lines. It is first line and it has skipped a second line. And here two tabs. Here again a new line. So next line also it will be skipped. There are two new line characters. First new line it will go to this one, and the second slash n will go to the next line. Then here I have inserted three tabs. That is why there are three spaces. Three or four tabs have been inserted, and also I have included some slash n. I have not, only one slash n was included. That is why it is goes to the next line. And what happens here? Hello, comma, and I have inserted a slash here. Even though I have inserted a slash, that is not printed here because it's just to show that the next line also is of the same line. That is why you can print like this. Okay. So all these things are possible. So that is the use of this escape sequence characters. Escape sequence characters. So you did not worry. You should understand that we can use the slash t, slash n, slash v, and all. We can insert inside this double quotes when we print and all, so that we can have this tab or new line characters or vertical tab. All these are possible, and we can include slash b for beep sound also. You try all these escape sequence characters inside the spread. You will understand what is the use of all these characters. Mm. And this also you can include so that you can show that it is these two lines are from the same printf statement. Okay, so that is the use of this escape sequence characters. Even though we have inserted no space between hello and world, since we have included the slash t, we have a tab, horizontal tab will be inserted. Similarly, we can have vertical tabs. If we give slash v, it will be vertical tab. It will skip some time and it will be world will be printed after that. So we won't be using all these things. Mainly we'll be using slash t and slash n in every printf statement. Maybe for new line, to print it in new line, we'll be using slash n. If we want to skip some tab, we'll be using slash t. Okay. So we'll go back to the slide. So that is about backslash constants. Then we have string literals also. So string literals, so it is enclosed in double quotes. So anything that is enclosed in double quotes can be used as string literals. It is similar to character literals. So plain characters, escape sequences, and universal characters can be included in double quotes. In character literals, we can have only a single character. But in string literal, we can have multiple characters. We will see an example. And we can break a long line into multiple lines using string literals and separating them using white spaces also. So this hello dear, we have already seen this example. So this is a string literal. So if we want to split into, we have already seen this example. If we want to split into multiple lines, we can have this kind of string. We will just have a slash here. Then all these lines belong to the same line. Then you can have this kind of also if we want to split into different double quotes. So if we include all this in a printf statement, all together will be inside a printf. Hello dear will be printed. So and you can include this characters 2021 also inside double quotes. Then 2021 is a string literal. So how to define these constants? So there are two ways to define these constants. One is using hash define and the other one is to use constant. So we have already seen how to define variables. Similarly, constants can also be defined. One is using hash define preprocessor and second using const keyword. Okay. So we will see const keyword first. So this is the syntax for const keyword. So const type variable equal to value. This is a general syntax. Const is a keyword used. Then type should be there, whether it is int or float or double. And we should give a variable name. We should give a name for that. All those variable naming conventions should be used. And we will be assigning some value. And this value will not be changed. So we will see an example program. So we will use the same program here. I'll just delete. I'll just delete these things. Escape. Okay. I'll insert something. So I'm going to declare a constant. So in variable you know how to declare. Now in order to declare constants you have to use const keyword should be used. First method is using const keyword, and int you have to use the data type. Then you can define a constant. Usually constants, in order to show it is a constant, you can use it as a capital letter. It is not mandatory that it should be capital letter. You can use small letters also. Usually we'll be using this. This is a programming step in order to show it is a constant. It is not necessary that you should always use a variable name as capital in capital letter. It is better to use this. So okay, constant, I am going to define another thing, width and equal to 5. Okay, now what I have done is I have declared a constant named length, and I have assigned some value 10, and I have declared another constant width, and I have assigned a value 5 here. Then I'm going to const char. I'm going to define a character constant also. I'll name it new line, and character constant should be assigned a value inside single quotes. So I am going to assign slash n. Okay, slash n semicolon. Now I am declaring a variable name area. So we have declared three constants and a variable. Now I am going to calculate area equal to, so we will learn about this operator later. Now simply understand that there is an operator, called asterisk, is just to multiply these two values. Okay, area. So here this operator means to multiply this length into width, that is 10 into 5 will be multiplied, and 10 into 5 is 50, and that value will be assigned to area. We will learn about this operator later. So it is just to multiply these two and it assign it to area. Now I am going to print f. I am going to print the value of area. Area is, since it is integer, I have to use percentage %d and comma area. Now I have used another character constant here. Now if I want to, I'll just print this and see this. After that I will come into this thing. I'll save it. Then I'll compile it. GCC. There are no errors. Now dot slash add out, and area is 50 is printed. Now it is not printed in this prompt is not in the new line because we have not inserted a new line there. So I'm going to insert a new line here. So instead of using slash n inside this double quotes, you can include a slash n inside this double quotes. Instead of that, what I'm going to do is I'm going to use printf percentage %c. I'm going to use the character constant here. So I'm going to print percentage %c. Okay, I'm just going to print percentage %c, and new line I'm going to print here. Okay. So what happens is new line, it is a character constant. So this percentage %c will be replaced by this new line, and new line it is actually slash n. So percentage %c will be replaced by slash c. Now I'll save it and quit. Now I'll again compile it and dot slash add out. You can see. So I'll So you can see that area is 50 and it is printed in a new line. New line is printed here. So that is also possible. So what I have done is instead of using a slash n, what I have done is I have used this type. And if I want, I can print it. Let me take it out. Okay, I will copy this line. Okay, I'll copy this line. I'll include it here. Now what I'm going to do is I'm going to print it twice. Now after percentage D, if I want, I can use percentage C also. Percentage C. The only thing is I have to specify that what is that percentage C. So what I'm going to do is I'm going to print a new line. And if I want extra new lines also, it is also possible. So I am going to, instead of using slash n, I am using percentage c, so new sorry, percentage small c. And what I'm going to use, I have to separate it by commas. I have to type all those things, new line, again a new line. So this is also possible. Now if I run this program, I'll compile this. There are no errors. Then dot slash a dot out. So area is 50. Here there is no new line, that is why there is no space here. Area is 50 is printed. Now I will include one more percentage c here in this line also. So I will include percentage c here also. Percentage c is included here. So comma new line. Now I will compile it and I will run it. You can see that area is 50. So there is a new line. Percentage C new line is there. So it is next line. Then I have, in this line I have used 3 percentage C. So it gives 3 lines and it will be printed here. Again there is a print of percentage C new line is there. That is why there are 4 lines here. Okay. So in this way you can use this escape sequence constant. So if you want to declare, so this length value cannot be modified. So if I try to modify this, so if I, in variable, when you saw that variable, we have seen that slash underscore number can be changed. But if I try to change this value, now I am trying to reassign this value, length equal to 50. Okay, I am trying to change its value, length equal to 50. Initially it was 10, and inside this program I try going to change this value to 50. So we'll see what happens. I have saved that program and again GCC. So there is a problem here. Cannot assign to variable length because it is of constant integer. So we cannot change the value of length. We cannot change the value of length. We cannot assign a different value for length inside the program because it is a constant number. So length value cannot be changed. So it is similar to that variable declaration only. Only thing we will be using const keyword at the front. This means length of it are constants. It is not necessary that you should use all capital letters. So it is better to use capital letters. That's all. All those variable naming convention is can be followed here also. You can start with underscore. You can start with small letter or capital letter. All those things are applicable for constants also. And this is another character constants I have used, slash n. So character constant can also be used. So we won't be using this character constant now. We will be mainly using this integer constants or float constants. We will see float constants after in the next way. So there is another way to use define this constant also. So that is one way using const keyword. Then there is another way to use the same thing. So we can use hash define identifier value. So this is the way hash define can be used. So it is a preprocessor hash, hash include. Similarly, we can use hash define identifier and there is no equal. We simply say the value. So we can write the same program in a different manner. Okay, so I'll use the same program. Now instead of all these things, I'll just quit this program. I'll use a different program. When define, I'll name it define.c. Okay, Now I'll insert this. So I'll be inserting, the first thing is hash preprocessor. So I'll be using hash include stdio.h. So this is a preprocessor command. Then after that I'm going to define, instead of const I'll be using hash define. So in order to define constant, you can either use const or you have to use hash define. And here we will not be mentioning any data type and all. We may not mention the data type. You can use length. So I'm going to write the same program here to calculate the area. Hash define width 5. There is no semicolon here. You have to note, when you declare this, it should be above, before that main function. It is outside that main function. It is included in the, it is a preprocessor directive. So it can be used, defined like this also. And the same thing, if you want to define a character constant, it is also possible. Hash define new line, and within code slash n. There is some problem with this key. Okay, slash n. So these are the ways. So the same program, instead of using const, we have used hash define. Hash define can be used, length. And if I want to declare another floating point return, that's also possible. Hash define, I'm going to define a floating point return. Let it be called pi value. Pi equal to 3.14. Okay. Or if you want to declare a string literal, that is also possible. Hash define string literal, let I name it str, and I'll declare it in hello. Okay, so I have defined some constants. So length, width, the new line. Then I have defined a floating point constant. Sorry, there's no need for this equal. So I'll just remove this thing. Sorry, function. So I'll remove this thing. So this way you can define string literal, then the main function. So all this, if you are using hash define, then it should be outside the main function. So it's a preprocessor directive. Hash, everything starting with hash is a preprocessor directive. Okay. Now I'll define int area. Now I'll calculate the area. Area equal to length into width. Okay, length into width. Then you can print f, sorry, capital, printf area. Area is, since it is integer, percentage d should be used, quotes, and area should be printed. Okay. Now, if I want to include a new line, I can include that new line here. Printf, we have already seen percentage %c. So percentage %c and new line character is capital new line. Okay. Now, if I want to print that string, it is also possible. I am not going to print all this. So I just simply defined, you can use str. If I print that str, you will get hello will be printed. All those things can be printed. I'm not going to print all those things. I just wanted to show how to define these constants. We won't be using this, all these type of constants. We might be using this pi and all. You can define this pi like this, and after that inside the program you can use, instead of pi 3.14, you can use pi into like that. So if I want to multiply, you can use this pi into here, but then area should be as floating point thing. Okay. Return 0. Okay, so I have written this program. Now I'll close it with a brace, so it is complete now. So here I have defined some constants. Length, it is an integer constant. We are not specifying the data type here. That's the thing when we use hash define, we did not specify whether it is integer or anything. It will automatically take it as. So it is another integer constant, this is a character constant, this is a floating point constant, this is a string constant. Okay. And inside this, I have calculated area as length into width. So length, instead of length, that 10 value will be assigned, and width, that 5 value will be assigned. Area is percentage d, that area value will be printed here, and a new line will be substituted. Now I'll run this program, wq. Now if you run this, I'll just compile this. There is some problem. Oh, sorry, it is not GCC. I have used a different name. So define. So it is define.c. So I'll compile that. Compiled. Now I'll run this program. You can see that area is 50 is printed. Okay. So vim. So define.c. It's like that. So even though I have not used all this thing, you can simply print this pi value also. If you want, you can print this pi value also. You have to use a printf statement. So if I want, I'll just insert. If I want, you can use this printf. Now if I want to print that pi value, you can simply print that, but only thing you have to use floating point. Percentage f should be used, and pi can be printed. Okay. I have to compile it again, and I have to run it. Now you can see that 3.1400 has been printed here. So that can also be printed. So here I have defined some constant values. You can either use this hash define, or you can use const keyword also. So if you are using hash define, it is outside the main program. It is included in all stdi or .h. It is like a header file. So all these are known as preprocessor directives. Preprocessor directives. Okay. Directives. So okay, so you can use inside this program, and these values cannot be changed. If you try to change length or width or new line, all these cannot be used inside the program. So we cannot change the value of all these things. Okay. So that's all about constants. So you can either use hash define, and you have to use an identifier. You can use a variable name for that, and you have to define a value. But when you use this const keyword, it should be like this: const that keyword, then you have to specify the type, and that name, identifier name should be given equal to some value should be assigned. Okay, that's all about constants and literals. Thank you.